Assalamualaikum. If you're with me, then please drop a comment or a reaction, inshallah. Ada ni pelajar-pelajar. Sebab dia cakap seorang-seorang. Any response from you guys who are watching right now? Can you hear me clearly? You can drop a comment down there. Anybody? So problem bila buat macam ni ialah dia punya lag. Lagging dia is approximately 20 seconds. Kita cuba je dulu, okay? Let's just wait a few more minutes for your other friends to come in. How is the quality of the audio and the video? Okay ke tak okay? Okay. Ada tak lagi kawan-kawan you all yang tengah cuba masuk? audio quality is okay. Okay, sir. The audio is clear, sir. Alhamdulillah. But there are only 8 of you. 9. We'll just wait until we hit the number 15, and then we'll start. Naufal ada, Naufal? Saya buat awak jadi ni lah, nama istilah dia, moderator lah. And then if anybody who wants to request to join the group, can you just approve them for me whilst I'm presenting? Boleh ke? Boleh lah At least function sikit lah kan. Jadi kelas rap. Kelas rap waktu PKP. Okay, 1 minute kita mula lah InsyaAllah. So this is the first time we are going to try out FB Live. I'm not sure whether the other lecturers have already done this before or not. So probably you can just drop a feedback there. InsyaAllah. We'll start our session with Kitab Al-Fatiha. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين إن الحمد لله نحمده ونستعينه ونستغفره ونعوذ بالله من شرور أنفسنا ومن سيئات أعمالنا من يهدي الله فلا مضل له ومن يضلل فلا هادي له نشهد أن لا إله إلا الله ونشهد أن محمدا عبده ورسوله أما بعد. Okay, boys and girls, Alhamdulillah, we are here today for our tutorial question review, basically on the second part of chapter 9, which is on superposition. Just for you to know, for the past 2 weeks, especially during PKP, we had waves part 1, part 2, waves part 1, part 2, and then we had superposition part 1, and you just completed part 2. Alhamdulillah, thank you very much for everyone who have already submitted their feedback notes. I've gone through all of them. Now it's a matter of me putting down comments on each and every one of your submission. So these 4 are actually, we can call it clusters, which I will explain towards the end of our session today, inshallah. Okay, so proceeding with the tutorial question straight away. Hopefully the sound and audio, everything is alright. So we'll just start, inshallah. Okay. The first question on your tutorial is basically dealing with double slit, or you can call it the Young's double slit experiment, where we have a coherent light of wavelength 590 nanometers, which is actually, who can tell me if we have a wavelength of 519 nanometers, so what color of the light are we expecting here? Okay, drop down in your comments, inshallah. So basically, most of what, based on your feedback, you guys mentioned that it's actually a repetition of SPM. So for me, it's macam satu kelegaan lah kan. So I expect full marks ataupun excellent marks lah in your test, which is going to be tomorrow and day after, on Thursday and on Friday, inshallah. So you can just drop down what is the expected color of the wavelength if we have a 590 nanometers. So it goes through a double slit as shown in the figure. The separation of the slits A and B is 1.4 millimeters. Interference fringes are observed on a screen placed parallel to the plane of the double slit. The distance between the screen and the double slit is 2.6 meters. At point P on the screen, the path difference is 0 for light arriving at P from the slits A and B. Okay, so hopefully the slides are, can you see the slides? Slide tu bergerak tak sebenarnya? Ke saya short sendiri? Tak kan? So berjalan lah hopefully. Okay. First question, we go straight away. Determine the separation of bright fringes on the screen near to point P. So kalau dia bright, that means is referring to the constructive interference. So dia punya pattern is bright, bright and dark. So we just have to use the formula that's available in your notes. Y equals to lambda D over D. So Y is actually the distance that we want to determine, which is the separation of the bright fringes. Lambda is the wavelength that is given. D is the distance from the double slit to the screen. And then we've got the small d, which is the size of the slit. So you substitute the values accordingly. Make sure you substitute using the correct magnitudes. Nano is minus 10 to the power minus 9. Milli is 10 to the power minus 3. And then you will get the value straight away, approximately equals to 1.1 millimeters. So why do you have to convert it into millimeters? Because the separation, the question is actually asking you to separate, to provide the answers in millimeters. Okay. And then for question 2, so it says here the variation with time of the displacement x of the light wave arriving at point P on the screen from slit A and from slit B is shown respectively. But for the first part, dia tak guna pun graph ni. Dia saja je to catch you off guard. So dia kata state the phase difference between waves forming the dark fringe on the screen that is next to point P. So kalau lah the first question, it was asking about the bright fringe next near to the point P. Before we actually reach the bright fringe, dia ada different dark fringe. So sepatutnya lebih kurang macam ni So siapa yang jawab yellow, alhamdulillah, good job. Boleh tuntut claim hadiah daripada kelas rap juga, insyaAllah. Okay, so we have a bright fringe. Kat tengah-tengah tu is order 0, path difference is equal to 0. So path difference is basically the difference between two waves that are traveling. How do they differ kat situ? So the second one, so this is the one, the dark fringe. So the path difference, kenapa dia dark? Kenapa dia ada dark? Kenapa dia ada bright? Because bright dia adalah constructive interference. Kalau dia dark, maknanya dia destructive interference. So how can we achieve a destructive interference? Is only when the phase difference is exactly 180 degrees. So we have a crest intercepting with a trough where the resultant, based on principle of superposition, the resultant wave would be 0. So kat situ, sebab itulah dia kalau ikutkan dia punya jawapan tu, destructive interference, both waves are totally out of phase with phase difference at 180 degrees or pi radians. So dia tak minta lah explanation tu, tapi from just for the sake of understanding, kenapa boleh ada dark fringe tu is because of destructive interference between the crest and the trough. And that can only be achieved when we have a phase difference by 180 degrees. Okay, that is the first question of part 2. So determine the ratio. So this is where you have to use the graphs above. Okay, so ada request untuk nak masuk dalam group ni. Hopefully kita punya class rep boleh function lah. Minta maaf Novan, terpaksa sub kan. Sebab sepatutnya orang-orang masuk group ni awal, bukannya sekarang kan. I mention it, I think yesterday ke day before yesterday kan, untuk masuk dalam group ni kan. Tapi itulah, sekarang baru nak masuk kan. So cannot do two things at once lah. So determine the ratio intensity of light at a bright fringe to the intensity of light at a dark fringe. So here we know that the relation between intensity and amplitude is I is directly proportional to A squared, where A is actually the amplitude. So apa yang kita kena buat? We just have to count from the first graph is the first wave, which is 2.0 units, and then the second graph is 1.4 units. So kat sini kita boleh tahu dia punya constructive interference dengan dia punya destructive interference. Kalau constructive interference maksud dia is between a crest against a crest ataupun a trough against a trough. You can just take either one. So 2 plus 1.4. So the maximum amplitude is 3.4. And then the destructive interference is 2 minus 1.4, which is 0.6. So here you have amplitude of CI is equal to 3.4 units. Maximum at the bright fringe, amplitude of DI is 0.6 units. Since I is directly proportional to A squared, therefore ratio of bright against the dark light is actually 3.4 squared over 0.6 squared is equals to 32. So that is the value of the ratio. So hopefully this is straightforward for you guys. If you have any questions, you can always ask in the comment section below. Right? So proceeding to the next question. So it is actually a similar setup. So what is interesting in this question, sebenarnya dia banyak tanya tentang konsep dalam chapter ni. So we just go through in order to strengthen our understanding, insyaAllah. So first question is explain why one laser and two slits are used instead of two lasers to produce a visible fringe pattern on the screen. So the answer is to produce coherent sources, which is actually referring to the basic definition of coherent sources ataupun coherent waves are waves that have constant phase difference. So dia bukannya ada any other particular reason kenapa dia nak coherent sources ni. Basically the purpose of having a coherent source, two coherent sources, is actually to produce a visible fringe pattern. That's it. Bukannya nak kata kalau tidak ada coherent sources dia tak akan ada interference. No, interference will occur even if the sources are not coherent. Cuma to obtain a visible fringe pattern, that's why we need a coherent source. So what does it mean by a coherent source? That means it has a constant phase difference between each other. Okay. So yang ni basically terminology lah kan. So if you have any questions, you can ask, insyaAllah. Alright, question part 2. State the phase difference between the waves that meet at point B. So B is actually the first order of a bright fringe right after the center one, which is C. So basically it's either 360 degrees or 2 pi radians. It's actually referring to a constructive interference kat situ. Okay. Alright. So semua okay lagi setakat ni. And then moving on. 180 degrees is for point P, which is a dark fringe. So dia separuh lah kan. So dark fringe correspond to a destructive interference. State the principle of superposition. So dia bagi 2 mark kat situ. When two or more waves meet or overlap ataupun interfere within each other, the resultant displacement is a sum of displacements of each wave. So kat sini kita boleh ingat balik, kalau kita letak satu reflector at the end of the travelling incident wave, dia akan dapat reflective wave. So incident, the interference between incident and reflective tu akan hasilkan what wave? So answer in the comment section. Alright. Number 2, use the principle of superposition to explain the dark fringe at P. So inilah soalan yang sebenarnya perlukan explanation compared to the previous question. So what is the answer? The dark fringe represents destructive interference. Macam yang Daniel cakap lah, dia kata constructive and destructive. Although I'm not really sure what does he mean. Tapi kalau dark fringe represents destructive interference, when a crest interfere with the trough, they cancel each other out. Okay, straightforward. In figure 6.1, so calculation kat sini, the distance from the two slits of the screen is 1.8 meters. The distance CP is 2.3 millimeters and the distance between the slits is 0.25 millimeters. Calculate the wavelength of the light provided by the laser. So you can actually use the same formula. You code that formula, you get 1 mark, and then you substitute. Make sure you substitute the correct values, and also make sure you convert the correct magnitudes so that all of them will be the same. So kat sini yang mungkin menjadi kesilapan setengah orang is actually the value of y, because the value given 2.3 millimeters ni is actually between a bright fringe and a dark fringe. Okay, tapi y is actually the value between two maximums. Okay, two maximums. So you have to multiply it by 2. So what does it mean kat sini? So kalau you tengok kat sini, 2.3 millimeters is the difference of what? Between the distance between C and P. Itu yang dia bagi. Tapi yang kita nak ialah C and B. So it's actually double. So kat sini lah dia cuba untuk nak trap you all. Kalau siapa yang jawab straight away 2.3 tu tak dapatlah markah. Okay, dia mungkin dapat markah kalau dia code dia punya equation betul. Equation of a double slit experiment. So the value of the wavelength is 639 nanometers. So what is the value ataupun what color is the laser kat sini? Also answer in the comment below. Okay, tak ada siapa komen ke? Memang tak ada. Alright. So I'm not sure, you guys boleh boleh nilai sendiri whether lebih bagus guna FB Live ni ke ataupun guna Google Meet ke ataupun Webex ke. Tapi Zoom kita tak try guna. Alright, moving on. Yes, Hazimi, the answer is red. Tutorial 5 is a May June 2010 paper. Is the first version, question number 4. So this is question number 5 in your tutorial book, inshallah. Right? A laser produces a narrow beam of coherent light of wavelength 632 nanometers. So this is a red light juga lah. So dia memang suka red light pointer. The beam is incident normally on a diffraction grating as shown in figure 4.1. Spots of light are observed on a screen placed parallel to the grating. The distance between the grating and the screen is 165 centimeters. So tengok dia bagi centimeters. The brightest spot is P. The spots formed closest to P and on each side of P are X and Y. Calculate the number of lines per meter on the grating. So yang ni dia lain sikit lah. Kalau ikutkan tak adalah satu formula that was given dekat dalam you all punya notes kan pasal benda ni kan. Tapi okay, that's the purpose of using this exercise lah. Okay. On. Ada bunyi anak menangis. Alright, moving on. So calculate the number of lines. So firstly, what do you do? What can you do? Okay, because this is a diffraction grating compared to the normal double slit ke apa, yang mungkin significant kalau kat sini adalah diffraction grating is we have the angles kat sini. Okay, so we can actually obtain the angles by using arctangent. We have a 90 degrees triangle kat sini, insyaAllah. So 76 divided by 2 over 165 centimeters, you get 13 degrees. And then plug into the formula d sine theta equals to n lambda, and then d is equals to n lambda over sine theta. Make sure you calculate, you press your calculator correctly, and then you'll get your answer. The grating spacing is 2.81 times 10 to the power, which is micrometers lah kan. So this is not the final answer, because it actually wants us to know how many numbers of gratings do you have per meter. So what do you do after this? It's actually you take the inverse of the value. So number of lines per meter on grating is actually equals to 1 over d. So you have 3.6 times 10 to the power of 5 lines per meter. So that is how small the gratings are actually. Okay. Alright, moving on. So kat sini sama juga, dia adalah bright, dark, bright, dark, bright, dark. Kat tengah-tengah tu sepatutnya bright sahaja lah kan. So you are using a monochromatic light, so that's why you have this type of profile. But if you use a white light, then you will have the rainbows. Okay. Alright. State what effect, if any, this rotation will have on the positions of the spots P, X and Y. So basically, dia just nak tahu you all punya kefahaman tentang what happens to the P, X and Y. So P basically, the brightest spot at the center remains the same, and X, P, Y are rotated 90 degrees. So dia yang in the slide kat situ tak adalah sama, tapi lebih kurang lah kan, cool sikit dia punya gambar tu. So finally we have a question here. So the formula lambda AX over D could only be used in Young double slit experiment. Yes, it is kat situ. Sebab grating dia memerlukan, because gratings have got lots number of lines. So, kalau kat sini dia kata almost berapa ni? 300,000 approximately lines. So very small lines. Kalau ikutkan, if you have a bright light, dia akan jadi macam prisma that could refract the white light into the 7 colors of rainbow kat situ. Okay. So for this one, you have to use that formula d sin theta is equals to n lambda. It's actually just the same. Kalau you play around with the derivations, sebab konsep dia lebih kurang sama. Cumanya kita skip sajalah. So we have a question from Hazimi Yusri. Sir, is formula given in the exam? That's a good question. So let's see in an example. Question paper. So this is an actual question paper that you can actually download online kat mana-mana. Lambat sikit. Hold on. So each question paper is standardized for you to know whether what are the formulas and what are the values provided to you. So see here, so we are looking at, these are the data that is given: speed of light, acceleration of free fall 9.81. But kalau kat sini nampak tak adalah speed of sound in air, dia tak bagi kan, so you have to know about that. Okay, and then for this one, these are the only formulas that are given to you. So kalau kat sini, sadly speaking, it is not given lah. So you just have to know, right? Okay, moving on. Okay. In another experiment using the apparatus in B, a student notices the distance XP and PY as shown in figure 4.1 are not equal. Suggest a reason for this. So what happens? Dia ada dua possibility sajalah. It's either the diffraction grating tak normal to the laser light, ataupun screen dia pun astute lah. So those are actually one of the two options available if you want to answer that question. The screen is not exactly parallel to the diffraction grating, kat situ. The grating is not exactly normal to the incident laser light. So that's it for our tutorial review questions. Macam straightforward saja kan. So alhamdulillah. Macam senang saja kan. So we'll see tomorrow. So let me just give you an overview of what we have already done during this PKP. So we have waves part 1, waves part 2. So we have superposition part 1 and superposition part 2. So kalau kat sini you tengok part 1 you have progressive waves. Sepatutnya progressive wave ni dia punya pair is actually stationary waves. So if you notice here, waves part 1 you have progressive waves here, and then superposition stationary waves there. So dia jauh sikit lah kan. Tapi we usually differentiate progressive or travelling wave with stationary waves kat situ. Tapi for some reason in the syllabus they separate it quite far. Hopefully you guys nampak lah dia punya relation guys tu. That's why I colourkan progressive and stationary tu dengan blue. And then of course basically there are two types of waves, progressive and stationary, where both of them can either be transverse or longitudinal. So dia ada dua dan dua guys. So boleh buat table tu. For a progressive, dia boleh jadi transverse and longitudinal. Stationary pun transverse and longitudinal. So analysis dia berbeza kat situ lah. And then part 1 you studied on wave equation. We studied on wave equation, V equals to F lambda. And if you notice, throughout our study, part 1 ke part 2 ke masuk sampai superposition pun, dia masih lagi main-main dengan the same wave equation, V equals to F lambda. Alright, and then part 2 dia macam pelik sikit, dia macam out of place sikit compared to the other chapters. We have the Doppler effect. Kalau ikutkan setakat ni tak ada lagi lah soalan dalam tutorial pun tak sentuh on the Doppler effect. Probably I could just make one question masuk dalam quiz dalam Telegram, tapi nampak gaya macam tak ada orang jawab kalau dia calculation sangat orang buat kita boleh jawab Telegram tu straight away kalau dia macam conceptual question kan, A, B, C, D. Tapi kalau nak melibatkan calculation tu dia macam lambat sikit nak jawab. Tapi okey, tu masih lagi tengah test try and error lagi. And then you have EM waves. So I highlighted in red because unfortunately you have to memorize the spectrum in terms of the frequency ataupun dia punya wavelength. All of the electromagnetic waves including visible light, the 7 lights. And then you go for superposition part 1, you have got principle of superposition. That is actually the basis. And itulah yang the basis of stationary waves kan. Because the definition of stationary waves kan is actually an superposition ataupun interference between the incident and reflected. Okay. And then you got 3 cases. Kalau ikutkan dalam part 1 tu kan, always remember string, closed pipe, open pipe. You've got a node and node, node, antinode, and antinode and antinode. And then superposition part 2, you got Huygens principle, a Dutch fellow. So yang ni dia taklah akan tanya what is Huygens principle ke apa, tapi dia just provide a basic understanding lah. Because when you have a wave going through a slit ataupun a double slit, how come those two can actually emit waves according to like a spherical shape? That is because of Huygens principle. Dia kata any particle in a wavefront is actually can be considered as a source emitting their own wave. So bila kita ada coherent waves moving towards the slit, dia macam nampak straight kan. So kalau straight kat situ bukannya bermaksud the source is actually straight juga, tak. The source is actually a point source juga lah kan. Sebab kalau kita tengok dia punya setup experiment tu, dia masih lagi guna ripple tank kat situ kan. So guys lah. Amir, Syahmi, how about refraction? I'm not sure what is your question on that. Refraction tu maksud dia apa? Maksud apa? Refraction dalam chapter ni ke? So dia kata, Puan Halili is here, Masya Allah. So she responded to the person who did not prepare a calculator while answering the quiz in Telegram. It's good advice. So dia kata, kalau kita tengok the superposition part 2 here, we've got interference, constructive and destructive kat situ. And then we've got diffraction. Always remember there are 3 cases. We've got single slit, double slit and diffraction grating. So with single slit, you have just one. Dia ada double slit, Young's double slit, and you have the diffraction grating. So refraction, is it in our syllabus? Dia almost similar to diffraction, tapi within this scope, from what you have already studied kat sini, dia main lebih banyak kepada diffraction kat situ. Alright. So these are the main parts of anything to do with waves, part 1, part 2, and superposition part 1, part 2 that you already been doing throughout the weeks in PKP lah kat situ. Okay, any other questions regarding this? I think this is actually just a brief overview. Dia taklah cerita the entire details, sebab kalau if I list down all the detailed parts, then it will become another lecture altogether. So these are just a bird's eye view on what you have already done. So basically tomorrow on Thursday, you will have your test, which is covering part 1 and part 2 of waves. Okay, waves saja. On Friday, on Thursday, waves part 1 and part 2. So you have to sorry, it's not on waves. Waves, you already had your test the other day. It's going to be on superposition part 1. Okay, superposition part 1, you have a specific test tomorrow. So you have to recall back the stationary waves as well as the 3 cases: string, closed pipe and open pipe. And on Friday, what we have already discussed today will be assessed on Friday, inshallah. So you'll be given starting from 8 o'clock to before 12 midnight for you to answer within the designated time on the questions that have already been given to you. Okay. Any other questions regarding this overview of our chapter? Okay. If you're wondering why I'm looking up, because I'm looking at another screen to boleh Puan Lini. Bird's eye view, eagle eye view. Not yet? So as for the tutorials, because we already discussed superposition part 1 and part 2, if anyone of you already brought back your tutorial from college, so you can actually start doing it. Okay. So what about the Telegram question? Is it clear enough? Because I did not get any response. We had 2 questions. Question 1 is on which is on the superposition part 2, and then the second question was on superposition part 1, because tak ramai yang jawab. I'm not sure. Okay, sebab faktor kalkulator jauh tu lah. So hopefully it's clear enough, the explanation that was given. Or is it another question yang kata Afika have a question in Telegram? Let me just check. Okay, my question here is CNP and also DNP are 180 out of phase. How about B and P? B and P. Is there a point B? berdiri atas kerusi. Tapi kita tak nak tengok video dia orang sama ada. Are they actually doing it? Okay, B and P, I'm not sure. Afia, you are referring to which one? Ni siapa sebenarnya? Afika, sorry, Afika. Oh, you made your own B point. So B and P. So, okay, right, no wonder. So I'm not sure. Can you guys see the point? So if C and D are in phase, C and P are out of phase. D and P are also out of phase. P and Q are in phase. So now we have another point, B. So Afika drew it herself, B. So as I already mentioned in the last tutorial, it's actually a riddle. Dalam banyak-banyak cara macam mana kita nak berhentikan waterfall kan. How do you want to stop a waterfall from flowing? So the answer was we take a picture of it. So bila kita ambil gambar, waterfall tu berhenti kan. So sama juga dengan ni. So this standing wave is actually a snapshot of what is happening. So when you drew a point B, sebab kalau ikutkan the wave, standing wave is actually just a sinusoid. So that point B is actually point P, sama. Tapi by time it is actually vibrating up and down. So if you ask what is the phase difference between point B and P, point B is actually point P. Okay. Cumanya by time dia akan oscillate up and down because that is the definition of a standing wave. It's actually near you drew the B point is actually near the antinodes. When at a particular time, that particular is at P, and then it oscillates to point B, and then point P and point B. It's actually an antinode. So they are actually not only it is in phase, but it is actually the same point. It's actually the same point. Okay. Senang untuk nak respon terus dalam ni dalam Telegram. Oh yes sir, so it's the same phase ke sir? It's actually not the same phase, it's actually the same point. So yes, it is in the same phase. So to be consistent, we just draw it on the same graph, same line. Alright, sebab standing wave is not like a double helix of DNA. It's actually just the same graph. Okay, let's look at one example. I'll go for the bonus slide later. Superposition part 1, which is on standing wave lah kan. Okay, let's look at this example. Okay, so can you actually see here? Let's say we have point P and Q, whatnot. The standing wave is actually oscillating up and down. So there's no instance where you have, memang kalau you nak draw it in 2D on your paper, then it would be like a big and small like you had in your notes. But in actual real time, the waves are actually oscillating up and down. Okay, you can see it here. Can you see it here? So you are asking point B kat sini, point B, and then you have point P kat sini. But they're actually the same particles that are oscillating up and down kat situ. Okay? Boleh? Any other questions? Either dalam Telegram ataupun dekat dalam comment section pun boleh, tak ada masalah. I'm very sorry, my kids are going in and out. Probably that would create an interference. Okay, alhamdulillah. Okay. So let me just give you a bonus slide just for us to sign off. in the last 8 minutes. Okay, there's another question first. Let me just so when the line is at the middle means that is destructive. Are you referring to the middle at a node? Kalau dekat node, that means it's destructive. Yes, it is a destructive interference between the incident and the reflective wave. Okay. Okay. I can show you another. Let me just show you the slide. Sekejap, So recall the definition of a standing wave. Here you have, this is the incident wave. So kalau kita tengok kat sini, we have a reflective wave kat sini. So the interference between the incident and the reflective wave will cause a standing wave kat sini. So at the points that we term it as nodes, nodal points. So at the nodal points, you can see here, somewhere kat sini, kat tengah-tengah kat sini kan. This is where the particles, for this is an example of a longitudinal wave, the particles actually do not move because they get squashed from the other particles that are actually oscillating, especially at the antipodes. So kat sini kita tengok the middle one, although actually kalau ikutkan yang betul-betul, they are actually moving. Kan, kalau ikutkan dia punya moving, tapi because of the reflection, so kat situ dia akan interfere. Because of the interference we get at the nodal point, kalau kat tengah-tengah tu, that means it's not moving kat situ, right? So it's destructive interference. So when you have a destructive interference, the crest or the trough of the incident wave interferes with the vice versa. So you have the nodal points where it is actually zero kat situ. Okay, is it clear? So that is what we did last Friday. Any other questions before we move on? All right. So let's go for the bonus slide before we adjourn for the day, inshallah. I'm guessing you still have a long day after this with the series of lectures and whatnot. So this is the overview. Okay, so bonus slide, right? So relax, chill. So let me share it with you. Recall the relation between wave intensity being inversely proportional to the radius squared. So when we have already studied throughout the waves and superposition, you can recall intensity is either proportional to the amplitude squared or inversely proportional to r squared, and then you had another relationship between intensity. So what I'm focusing is actually on the radius squared. We had this one of the questions where you can prove this, where I is equals to power over area. The intensity is actually power over area, where we assume that the area is actually the surface area of a sphere. All right. So what is the formula for the surface area of a square of a sphere? Is actually 4 pi r squared. So we assume that the other factors are constant. So I is inversely proportional to IR squared. So now the further we can deduce from here is the further the position from the source, the position, that means the radius from the source. So the wave intensity at that particular point gets weaker, betul tak? As if this is adhered by the inverse square law kat sini. So you have this example. This is the source. So as the radius, because you are assuming this is a spherical or wave where it emits the intensity. So at point R, you have a certain intensity here.
And as you go further to R, the intensity will reduce. And it reduced by a factor of R squared, which is quite large. That's two. All right. So now, let's ponder upon this verse of the Quran. Allah subhanahu wa ta'ala says, A'udhu billahi minash shaitanir rajim. وَقَالَ الرَّسُولُ يَا رَبِّ إِنَّ قَوْمِي اتَّخَذُوا هَذَا الْقُرْآنَ مَهْجُورًا. And he says, Allah subhanahu wa ta'ala says, and Rasulullah SAW, the Prophet SAW, Nabi Muhammad SAW said, O Rabb, O my Lord, verily my people have taken this Al-Quran as something that is being abandoned and forsaken. You can actually refer this in chapter 25, Surah Al-Furqan, verse number 30. So, Nabi SAW, he is telling us that there will come a day when his ummah has taken this Al-Quran to be forsaken. And of course, the translation here is forsaken or abandoned. Tapi kalau kita tengok dia punya actual Arabic word is mahjura. It comes from the word hijrah. So hijrah ni apa? Hijrah ni maknanya kita bergerak dari satu tempat ke satu tempat yang lain kan. So dia kata ittakhadhu, they had taken this Quran mahjura. That means he has not been taking this Quran closely to him, but he has taken it at a very far distance. That means he has abandoned the Quran. So here you can remember what happens actually. We as the Ummah of the Prophet Nabi Muhammad SAW has taken the Al-Quran to be very far from our lives, and he has nothing to do with our lives. And if we have any problems, we do not refer to the Al-Quran. Instead, we refer to other sources. So what happens if we ponder? Kalau kita ingat balik, imagine this. Instead of trying to synchronize our hearts with the Quran, if you can remember in the last on Friday, where we tried to explain standing waves between our hearts that are vibrating with the wave that is emitted by the Quran. It is reflected. We will achieve harmony when we ala bi dzikrillah tatma'innal qulub. When we remember Allah Subhanahu wa taala, our hearts will become calm. Especially during this PKP, semua tengah stress, semua tengah depressed, tak boleh nak pergi kedai mamak, tak boleh nak pergi keluar. But if you remember Allah Subhanahu wa taala, everything will be calm. So kat sini, what happens, the dichotomy is, instead of trying to synchronize our hearts with the Quran, Allah Subhanahu wa taala says by the words of Nabi Muhammad SAW, in his dua, it says, my people have taken this Quran as something that is being abandoned and forsaken. So instead of trying to synchronize and harmonize our hearts with the Quran, the vibration of our hearts with the Quran, we abandon it. And the fact is, the further we are from the Quran, the less effect of the Quran it will have on our hearts. So there is a point to ponder kat situ. So what do we have to do? So we need to go back to the Quran. Especially, subhanallah, kan, we are going to celebrate Ramadan in our homes. And especially untuk yang lelaki lah, boys, you guys takkan nak minta your dad jadi imam kan? Semua dah habis SPM kan? So kena, you guys lah yang kena pergi jadi imam kan? Gile-gile lah, so to speak. But my question to you, insyaAllah, how are we supposed to go back to the Quran? Because we looked at it on last Friday. We have to synchronize our hearts, our vibrating hearts with the Quran, in order to achieve peace, inner peace. But then, there is a reality that we are facing even today, isn't it? The reality that we are facing today is, we do not look in the Quran. Lagi-lagi kalau kita baca Al-Quran, we do not understand one word of it. Like say, for example, when we recite Qul Huwallahu Ahad, do we understand the meaning of it? The literal meaning, the literal translation, and what is the tafsir behind it, so that it will give an effect to our hearts. So this is the reality that we are living right now, which we have to change. But the question is how? So I have really given 3 questions for you. The first one was on the crest and trough. We have to make sure our actions are within the Sunnah of Prophet Nabi Muhammad sallallahu alaihi wasallam. How do we achieve that? And then the second question was to ensure that our hearts are synchronized with the Quran. We have to ensure that how do we want to ensure that it is always synchronized to achieve harmony as a standing wave? And then this is the third one. We want to go back to the Quran. We want to be closer to the Quran, because we know by the law of inverse square the further we are from the Quran, the less effect it will give us in terms of the quality, the quality of the person that is being developed from the Quran will be less. So inshallah, that's it. 1 hour. It's actually less than 1 hour. We started our session 10:45 lebih kurang. So if you have any questions, you can always ask me. It's either kita try to nak keep the Telegram group as a medium for us to discuss anything, and the Facebook group, this Facebook group that we already just recently created to broadcast our sessions. But in the end, kita cuba untuk nak discuss together, is this the best method? Sebab for me it's quite frustrating sebab ada lagging. Actually ada 20 seconds lag because I'm using a third party software apart from the feature that is available in Facebook. But we'll try to progress. We've got 2 more weeks dekat PKP ni. This is the first day of the third phase. Pray to Allah SWT that He will give us the harmony that we always long to have, insyaAllah. Wallahu a'lam bishawab. If there are no more questions, I guess we can call it a day. So, aqulu qawli hadha wa astaghfirullah li wa lakum. We will adjourn with tasbih Farah Surah Al-Asr. Subhanakallahumma bihamdik, ashhadu an la ilaha anta, astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal asri innal insana lafi khusrin illa alladhina amanu wa amilus solihat wa tawassaw bil haqq wa tawassaw bis sabr. Alhamdulillahirabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.